The mousetrap car. A vehicle powered by nothing but a string and a mousetrap. A staple in every entry-level engineering class. Some call this invention a gift from the gods. Proof of divine intervention. And they'd be wrong, of course, but the metaphor is fairly accurate. The mousetrap car was invented by James Henry Atkinson in the late 19th century, and although he reached upon the peak of human engineering, he didn't quite reach it. You see, there is one glaring flaw in many modern-day mousetrap car designs, one which I've encountered personally last year while making my own mousetrap car, and one which I've spent the majority of my first semester of my Engineering 2 course seeking to solve. As the hinge of the mousetrap retracts, taking along with the string which is tightly wrapped around the axle, the string will sometimes get stuck, tangling the string and preventing the mousetrap car from functioning. However, thanks to my invention, I believe I've solved this issue. Now, this invention of mine didn't just appear out of thin air. I mentioned that it took the majority of my first semester to create, and that certainly wasn't an understatement. This process starts with learning Fusion 360. In years past, the engineering curriculum has used SolidWorks for all CAD-related activities. However, due to the coronavirus and every student needing their own personal laptop, each laptop will need their own license for SolidWorks as well. Now, these licenses are not cheap. Therefore, we've had to seek a free alternative in the form of Fusion 360. And while Fusion 360 certainly has its drawbacks compared to SolidWorks, it's still an adequate software. However, being that it's a new software, we had to spend a good portion of the year learning how to use it. Once I became proficient in Fusion, then came the time to start work on my part. There are multiple iterations, although the general shape remained the same throughout the entire process. One cylinder with threads along the side, designed to hold the string to prevent it from getting tangled during the release of the mousetrap car, as well as a patterned hole throughout the entirety of the shape, designed to fit exactly along the Lego axle. Once the design was finalized, it came time to 3D print the part. Despite the massive amount of work already put into this project, there was still far more to be done. Now that the part was complete, we had to design a packaging for it. Just like with the part, the box went through multiple iterations before coming to the final design. The final design, which takes inspiration from a pizza box, requires no tape or adhesives in order to be fully closed. Instead, it only needs to be folded in the correct way to function properly, which, in a real-life professional setting, would cut down on production costs drastically. The box uses 5 rectangles, which act as the front, back, top, bottom, and cover of the box. From there, these rectangles have tabs along the sides, which gives the box its structure. The small tabs along the bottom and middle rectangle fold inwards. From there, the very long tabs along the second to bottom rectangle fold 3 times. The ends, with a slightly larger width than the rest of the tabs, fold into the bottom of the box and then push against the sides. This prevents the rest of the tabs from coming up. Then, the middle part in between the end with the larger width and the main rectangle fold into 2 equal sized parts. Those tabs fold over the smaller tabs from the middle and bottom rectangle. It allows those tabs to stay in place, as well as gives the quarter circle tabs in the very top part somewhere to fold into. While the other tabs keep the box together, the quarter circle tabs act as a locking mechanism, keeping the box closed. The final folded product then looks like this. Once the design was finalized, came the actual making of the box. To do this, we use a machine called CryCut. To use this machine, you would have to get a drawing of your Fusion 360 model. From there, you would put it in the CryCut software, make any changes you wanted to, or add any artwork to your box, and then upload it to the CryCut machine. From there, you would load a piece of medium cardstock on a specialized piece of plastic designed to feed into the machine. Once it was fed into the machine and the file was uploaded, it was ready to start construction. Here is a video of the CryCut cutting out my box, sped up by 600%. All that's left to do now is to fold the box together. Now, although this is the end of my design process, there's one more step that I did not get to due to a lack of time, and that would be designing a buck. This buck would be used with a vacuum forge to create a plastic mold for your piece to go into inside of your box. You would design this by making a rectangle in Fusion 360 with dimensions slightly smaller than your box, and making an indent within it the same dimensions as your part. You would then 3D print this buck and place it in the vacuum forge, where heated plastic would fall onto the buck and then quickly harden, making a thin plastic shell for your piece to go into within your box. Once you cut out the shell and place it in your box, you're left with the product and packaging made with the same method used by industrial manufacturers, as well as a solution to the problem that has plagued mankind's greatest technological achievement for over a century.